All right, so what we're going to start out with is knowing the difference between a secant line and a tangent line. All right, first off, definition of a secant line. It's a line that's going to intersect a function at two specific points. So I'm going to draw what that function looks like. Here, I just have a regular old quadratic, and what I'm going to do is I'm just going to draw 2 points, and I'm going to connect them with a line. All right, now when I draw that line, you can see that the function, the quadratic, just got intersected by two specific points, and that's that secant line. So that's the definition of a secant line. The next one is going to be our definition of a tangent line. Now, for a tangent line, what it's going to do is it's going to intersect at one specific spot. And I'm going to do the exact same thing where you're going to be able to see what that function is going to look like. All right, so we're going to have the same idea. We're going to draw up a quadratic. All right, I'm going to take one line, draw 1 point on that quadratic, and I'm just going to draw a line through that specific point. So we need to know this difference between a secant line and a tangent line. The reason we need to know this is because eventually what we'll do is we'll take that secant line and we'll turn it into a tangent line. And I'll show you how we can do that using the calculus that we have learned up to this point. All right, so that's our difference between our secant line and our tangent line. Secant line, we've got 2 points. Tangent line, we've got one specific point. Now, here's my question. How does a secant line turn into or become a tangent line? All right, that's the one question. That's what we're actually going to use. And what we're going to do, and the way we're going to be able to accomplish this, is using some calculus, and it's through using slope and using limits. All right, so we just did a bunch of limit stuff, and we're going to be able to identify how to be able to change a secant line into a tangent line by taking slope and taking limits. But the first thing that we need to do is we need to find the slope of a secant line. All right, so that secant line wants to become the tangent line. All right, well, first off, let's find out that that slope of the secant line. All right, so the secant line becoming a tangent line means that the distance between our 2 points on our secant line, so we got those 2 separate points on that first quadratic, they were separated. The distance between those 2 points actually needs to approach 0. And this is where calculus comes into play. That's where our limit comes into play. Our distance between those two values needs to approach a specific value of 0. Basically, these 2 points almost become 1 point. Now, I'm going to explain that you can't have just 1 point if you're trying to find slope. Algebraically, the minimum amount of points that you need in order to find the slope between anything is 2. You need those 2 values. You need those 2 separate points. You got to have a separate distance. So what I've been always saying throughout for our limits is that limits don't actually equal that value. They approach that value. So really what's happening is I've got this distance. Say my distance between the 2 points is 5. I'm going to start cutting down that distance. Maybe the distance between them goes to 4, and then to 3, the 2 to 1, then 0.5, 0.1, 0.01, 0.000001. It's gonna basically look like we have 1 point, but really there still is 2 points, so we can still find the slope. My distance cannot be equal to 0 between them, because then once again I don't have a second point. I need that second point. So that's why calculus comes into play. We're using this definition of a limit as we approach a specific value to help us change a secant line and turn it into a very, very close tangent line. All right, so secant line to tangent line means the distance between 2 points approaches 0, which means our limit of that distance is going to approach 0. Well, first off, what is the slope of that secant line? All right, that's what we're going to come up with now. So let's figure out how to find the slope of the secant line. And I'm going to do this in a general way. I'm not going to use specific values. All right, so once again, here's my quadratic. I'm going to draw my 2 points up there, and that's going to create my secant line. Now I'm not going to connect them. That's just going to be my 2 points that I would use. Obviously, if I connected them, I do have a secant line. I do have a line that intersects that quadratic at 2 specific points, and that's the definition of a secant line. Now what I have is my first point is A. My second one, I'm just going to add a distance to it. So I started at A. I add a distance of h to it, and now I've separated. Now I do have 2 specific points. So you can see that the first x value that I'm using is a, the second x value is a plus h. Right? So that distance between those 2 points right now on the x-axis is going to be h. Well, remember, these are points. They have x values, they have y values. If I want to find a y value, I'm going to take the x value and plug it into my function. Right? So I'm going to label out these 2 points. The first point is the x value is a, and in order to find the y value, I'm going to plug it a into my function. So it becomes f of a. That's my y value. If I want to find a y value, take your x value, plug it into the function. So there's my first point. I'm going to do the exact same thing for my second point. Now, I changed my x value. My x value is no longer a. My x value is now a plus h, which means my y value has changed at the exact same time. If you change your input, you're changing your output. All right, so the input for the first point was a. I plugged in that input of a into my function to be able to find y. That's why I wrote f of a. Well, now my input is a plus h. I'm going to plug that into my function, and that's going to be my y value. So my y value becomes f of a plus h. I plug my x value, this new x value, a plus h, into my function to be able to identify what this new y value is. So we needed to have these two specific points. Now that I have 2 points, we can actually go ahead and find the slope between these 2 points. All right, so right now we're just starting out basic. We're going to say, hey, how do you find slope between 2 points? I'm going very, very general. All right, and since we have 2 points, remember the slope is just how did your y's change over how did your x's change. So change in y over change in x. Delta y over delta x. All right, I'm going to write down here, really what's happening is we're going to take my second y value, my f of a plus h. I'm going to subtract my first y value. That's how my y's changed. And I'm going to divide that by my second x value, which is this a plus h, and I'm going to subtract it from my first x value, which is a. So we're just using these 2 points and finding slope like we normally have before. There really isn't anything different. The only difference right now is I'm using a lot of variables, and I'm going in general. So that's how we find the slope of a secant line. All right. Well, now what we want to do is we want this secant line to turn into our tangent line. So how are we going to be able to accomplish that? How are we going to take it from 2 points to a single point? So the way we're going to do this is that we want this distance between these 2 points, that h value that I wrote on the bottom of my graph, what I want that to become is I want that distance to close. I want to push that point closer and closer and closer to my original a value. So if my original a value was 4, I want that distance between it to be so gosh darn small, 4.0000001. It's basically 4. All right, but they do have to have a little bit of separation. I do have to have 2 points. All right, so we're going to take this distance between these 2 points, this h value. It's going to approach 0. That's where the calculus comes into play. That's where limits come into play. And we've been doing a lot of limits lately. All right, so that's why I'm writing this down. The only way to do this is by taking limits, by taking a limit. That's calculus. So here we go. I'm drawing the same quadratic. Here's my original point, A, all right, which means I'm going to write out my actual full point, A, comma, f of A. So there's my x value and there's my y value. Now I'm going to draw a point extremely close to it, all right, as best as I can. And there's my second point. Now remember, you're not really going to be able to see the second point because the distance between these 2 points is so minuscule, it's basically 0. But it can't be 0 because you cannot have the same point on top of itself and find the slope between one point. It's impossible to do that. All right? So I'm going to write my second point as a plus h, and then there's my actual second point, which is my x value, a plus h, and then my y value, f of a plus h. So you can see that all I did was I closed the distance. So my secant line is getting closer and closer and closer to a tangent line. All right. So that's what we're trying to do. That's how we're accomplishing this. That's how we're taking a secant line and turning it into a tangent. All right. So the closer these 2 points get, the closer and closer it gets to becoming a tangent line. And that's what we want. The closer the secant line is changing, the closer we go from 2 intersection points to actually having 1 intersection point, which is my tangent line. That's what we're trying to do. That's what we wanted. So as you can see, the closer these 2 points get, the closer the secant line, which was 2 intersection points, becomes a tangent line, which is actually going to be 1 intersection point. Now, here's the other part. To be able to do this, to be able to still identify this slope, what we're going to do is we're going to take a limit. And we're going to take the limit of the secant slope. The slope of that secant line. Right now, we don't know what the slope of the tangent line is. We don't have that information. But we do have the information from the secant line. So what we're going to do is we're going to take that information from the secant line, and we're going to apply a limit to it, our calculus stuff. And we're going to turn that secant line into my tangent line. So to do this, we're going to take the limit of the slope of that secant line. And that's where this next part's going to come into play. So the slope of the secant line, I'm going to write out what our 2 points were. Remember, this is in general. My first point was A. If I want to find the y value, I'm going to plug it into my function to be able to get that. That's where I got f of a. Remember, I have a second distance to it. I added something to it. I separated, so I did have 2 specific points. I added a value of h to my x value, so now it's a plus h. Well, that changes my y value to f of a plus h. So there we go. There's my secant points. Now, I'm going to find the slope of this secant point, all right, these secant points. That's just my change in y over change in x. Well, my change in y is my second y value, f of a plus h, and I'm going to subtract my first y value, my original y value, which is f of a. I'm going to divide that by my new x value, my distance that I added onto it, a plus h, and I'm going to subtract my old x value, my original one, my a value, all right? Now, in order for us to be able to find the tangent slope, slope of the tangent line, we're going to take this secant slope, the f of a plus h minus f of a, divided by a plus h minus a, and we're going to start to apply calculus. We're going to start to apply our limit. So what I want is that distance between these 2 points to approach 0. I want these 2 points to get so gosh darn close, it looks like it's a single point. So really what we're doing is we're taking the limit as the distance between the 2 points, h, goes to 0 of my secant slope. I'll show you what that actually looks like. Instead of writing secant slope, we now know what our secant slope is. My secant slope is that f of a plus h minus f of a all over a plus h minus a. So this limit, the slope of the tangent line, is the limit as the distance between the 2 points approaches 0 of f of a plus h minus f of a all over a plus h minus a. Now what I'm going to do is I'm going to simplify that denominator. That denominator, the a minus a, just cancels each other out. Really what we're interested in is what is the change in my x value, what is the distance between those 2 points? What is that actual value? Now we're not really going to care about that. We're not going to know the specific x value, and you're going to see why, because when we start taking limits and start applying this stuff, you're going to see what's going to happen with that h value. So really, the slope of our tangent line is the limit as h approaches 0. Remember, that's the distance between my 2 points. They have to close in. They have to close that gap. As h approaches 0 of f of a plus h minus f of a all over h. So that is how we find the slope of a tangent line. So we need 2 points to begin with. We need a secant line. And then what we're going to do is we're going to take those 2 points and push them so gosh darn close together, it's like they're 1 point. That becomes a tangent line. So we take a secant line, we use the slope of the secant line, we use calculus, we use limits of that secant line to be able to turn it from a secant line to a tangent line. I know I'm saying the word secant a lot. Hopefully you understand what that means. All right, so the last piece is going to be this definition. All right, now the definition, this is how you find slope of a curve at any point. You don't need 2 points anymore. Everyone's like, oh, if I want to find slope, what's the basic information you need? You need 2 points. Actually, technically, you don't. All right? In fact, you only need 1 point. You need a function and you need a point. If you have a function and you have a point, you can find the slope along a curve anywhere along that curve. And you're going to do that by accomplishing what we just did. The slope of the tangent line, that's what we're using right here. So to find the slope of a curve at any single point, and we're going to put this in our super important things to know, my function is y equals f of x, and I want to find the slope at this point, a, f of a. Okay, well, if I want to find slope, and I only have 1 point, but I have a function, I need to take a limit. All right, they're basically saying, what's the tangent slope? You got 1 point, I'm going to draw a line through that specific point, that's a tangent line. Well, the only way I can find the slope of a tangent line is by using the slope of the secant line and using that limit. So I want the limit as h approaches 0 of f of a plus h minus f of a all over h. Now, this is true as long as the limit exists. Now, if the limit doesn't exist, then there's something else that's going on. We have to be able to investigate a little bit further. But that's how you find the slope of a tangent line, and this is actually how you find slope of a curve at any point if you have a function and only 1 point.